So welcome to AI in construction. So I've talked about a lot of AI topics in the past and have not gotten to robotics yet. And I'm super excited to have Henning Roedel, who's the founder of Hardhat Robotics, on to talk about what he's been up to. Henning will tell you his background, but he's been in innovation for a long time and has come at this after a lot of thought, which is a lot of the fun of having a webinar. So Henning, welcome to the podcast, and let's talk a little bit about what you do.
Yeah, thank you, Hugh. It's a pleasure to be here and excited to talk about robotics and AI. And so, just a little background on how I got to this position and what led me here. First and foremost, I love wild and crazy ideas, and I have no shame in saying that I want to go chase them down. And if it's not a challenge, it's not worth doing, is sort of my mantra. So, couple of years ago, I had the fortunate opportunity to work with DPR Construction, and I joined their corporate innovation team. So we were always on the lookout for new technologies, and we were sort of the 0 to 5 team, meaning we'll take a idea or concept, find a way to address the challenge with any sort of technology, and then prove that that works, right? And if it does, then we can hand it off to the greater org. And robots at this time, this is 2019 to 2025, or excuse me, 24. Robots for construction were really starting to hit the market. And in my region, in the San Francisco Bay Area, there were a few startups, right, like Canvas Robotics and Dusty Robotics, who were the sort of front runners in all of this. So I said, we'll give you a shot. We'll see. And I honestly thought, given the construction industry's sort of, especially in the Bay Area, like it's a union heavy area. I was going to get threats, and the job site was going to be shut down, and we were going to get in trouble for introducing automation. But we took the risk, and to my surprise, it was the opposite reaction from the folks in the field, right? They were taking selfies with the robot. They were happy and excited. They understood the value proposition immediately. And then when we got to testing the work, and we were testing the robots and comparing it to traditional methods, traditional approaches, the robots were faster, right? And it all of a sudden it started to click, like, hey, there's some real opportunity here, right? Like the biggest resistance in my mind had been eliminated, and the industry was ready for it. And it's only gotten more so over time. And so I worked out a deal with DPR to say, instead of 0 to 5, let me just focus on robotics, and we'll go 0 to 50. There's so much value to be captured here, and we need an internal organization for how to bring this technology into the field. And so the company agreed, and I'd been working on that. That was in 2022. So fast forward, we had tested a lot of robots. We had found a lot of value. But the robots were really doing just one thing, right? Like the hardware was really designed for that one task. And so the value was somewhat limited. And I figured that the approach was limited, right? And there was a technology coming out that was really exciting, which was diffusion policies, that was coming out of Toyota Research Institute. And they made a great video about, like, how does the technology work, and what is it capable of. And I was hooked, and I started sharing that internally at the company, and saying, like, we need to be on top of this. We need to look out for the startups who are working with this for our industry. And turns out there weren't any. And I asked the CTO, I was like, hey, what can we do here? The humanoids are coming. The hardware is extremely cheap, and that could be a threat or an opportunity. And he said, it's all well and good, but we're a construction company. We're not a hardware development company. And I thought about it some more, and I said, okay, well, why not me? And we left things amicably in summer of 24, and I formed Hardhat Robotics right thereafter. So it's a long story, but it gives a lot of context here as to
Yeah.
why we're talking about robotics and AI.
The ultimate startup story, right? Is you're working somewhere, you see something, the company either doesn't want to do it or just it's not what they do, and you say, well, okay, I found something. Well, I can't go any further without asking what diffusion policies are.
Yeah. So you're familiar with image generators, right?
Yep.
And you know how they start kind of blurry and then they become more and more in focus. What's actually happening is it's starting from a random static image, and the AI model has basically learned how to take images and convert them into those static images and right sort of control its pathway. And so it can perform the reverse of that. Take a static image with a prompt and generate the photograph. And so in robotics, a diffusion policy is the same technology, just applied to robotic trajectories. So given this input and this objective, right? So I want to move my arm or I want to move an object from this point to this point. What are all the possible different methods? And it turns out this method of taking a random static vector and transforming it into the robotic trajectory works quite well as well. So that's how a diffusion policy works.
Very cool. I had never heard of that before. So you mentioned something before that I want to get into, and this is that a lot of the robots that are out there are really narrow, and some of that, to me anyway, speaks to the limits of what AI and or robotics can do. And kind of this is the Venn diagram of the two, in that too much complicatedness, too much complexity, and they break down. They just can't handle it. So a lot of times you see single use or single function robots because something about that environment is simple. Layout is a great example, right? You had to sweep the floor to put the layout down anyway. You can't have things there. So you've simplified the environment. Tie, tie bot type things where they're tying off rebar, same thing, right? Like you can't just put it somewhere. It has to be a slab of a certain type and so on. And there's some others that are, the canvas is like that too with drywall, where it's a simpler situation than just walking up and installing it. But they're really fast once you've done that. And then in the case of layout robots, they wind up adding all these things like colors and different trades. I mean, it's really interesting where this is a great example of the layouts of once you've kind of done what the human would do because of the machine that you have there, it often opens up new things you wouldn't have even thought of, which to me is exactly what technological progress is about. Is you get to the goal, but while you're at the goal, you're like, well, hang on, we built this other stuff too, or we have this other stuff. Why don't we put different colors in there, or different parts of the drawing, or whatever it might be? But back
Exactly.
to the narrowness thing, a general point with AI is you usually do better when you make the problem simpler. And robotics seems to be a really good example of that. Talk to me a little bit about how you think about that. And it sounds like diffusion policies might be, I don't know if it solves that problem so much as gives you another tool to overcome it. But how do you think about that?
Yeah. So what I saw with this technology, and it's not just diffusion policies. There's another formulation called action chunk transformers, and it uses the transformer architecture rather than the diffusion one. But let's not dive too much into technical details. Um, so I just want to acknowledge it. What I see with this technology is you could use roughly the same um, hardware base and outfit it with various tools. And so you're changing just a small part of the machine, but you can still train a policy, teach it how to actually perform the work. And so that's the crux of all of this is you're actually the way you create the data for these robots. You perform it. You perform the task as like a teleoperator, right? Controlling the robot, and it's recording. It's recording its movements. It's recording camera views, and it's using that data to then recreate the movements uh, to to perform that work. But it's a lot more capable of handling exceptions, right? The side cases, that kind of thing, versus a classical method where you have to really closely define the parameters and what trajectories it has to move. This is more just show me and I'll figure it out. Which is really exciting. Now it's not exactly quite there yet. It still gets hiccups when the lighting conditions change, or this cable is different than another, is a different color of another one, that kind of stuff. So you still need a lot of data, to make this work, but it's in terms of programming a robot, much easier.
And yeah, and to your point about edge cases, now you're in a place where you can have the teleoperator, or I mean, well, let's actually, before I start solving the problem,
Yeah,
how does this help with edge cases?
you're hired. So
Yeah.
exactly. So in a sense that, like, what I like about it is you have a fail-safe with the human operator. So you can let the robot run, and when it hits that edge case, you can the operator will be there. They can remote in and just solve it themselves, and then you add to the data set, and that's actually really valuable data. And this is a technique that's been used in self-driving cars. But obviously we have a lot more compute, we have a lot more sensor technology, and we have the lessons learned from self-driving that we can actually start to apply that to what we call manipulation tasks, right? Dealing with our hands and manipulating items in the real world.
And for those who may not use the word edge case very much, if you think about like a kind of a normal distribution of when how often things happen, the original training run is going to be able to handle a lot of what happens very, very often. But the reality is that random things happen. And because those random things individually don't happen very often, you don't know to train for them, or you just don't at first. But the reason, for example, with self-driving cars, where every edge case could potentially be, not great, um, collectively there can be a lot of them. Individually, there isn't, like this particular thing doesn't, like somebody puts something where it shouldn't be, or something's a different color than you expected. Like individually they may not happen that much, but collectively there can be a lot of them. And that's again why in the past, prior to approaches like diffusion policies and just honestly modern compute, you really needed to simplify things because you didn't have a good mechanism to handle things that don't happen very often. So you needed to be able to just not encounter them. And what I'm hearing
Exactly.
you say is, look, we may not be there yet, but there's a pathway towards being able to handle the edge cases. And if you think about it, a construction site is one big edge case. Like the whole point is people are putting things here, they're putting them there. They're, the schedule isn't followed exactly the way it is. And honestly, we purposely leave lots of fuzziness because people are there figuring it out, as opposed to following, some really expensively laid out plan that would fail anyway. Like
Yeah.
the construction would never work if you had to plan every last detail, because if for no other reason, no one would pay for it. So it's like loaded with variables and things that might not be quite like you want. So what I'm hearing you say is that, as I say, there's at least two approaches to overcoming that.
Yes, yes. I don't know if I necessarily agree with everything you just said there. I'll push back a little bit. I think there is a lot more room for standardization in the industry. Don't get me wrong, but some of the beauty of the built environment, a lot of the beauty of the built environment, is the fact that it's one-off, custom, type things. But there's efficiencies to be gained. We all know that in our industry.
Yeah, otherwise we wouldn't be making robots.
Right, exactly, exactly.
Yeah. And you think it's interesting that the more you use things like robots or, automatic layouts or this or that, some of those variables, to your point, get more and more standardized, right? Like, and that allows things downstream. There's an interesting, to me anyway, an interesting output of using machines to do certain things is the tolerances they produce will be tighter than what a human would. There was a company that does a design tool that relates to steel. And because modern steel has much tighter tolerances than used to be true, and I'm thinking girders and
Mhm.
rivets and all that, you're able to do things with software now that's not. So the reason for the software being useful isn't inherent in the software. It's because the materials they're dealing with are so much tighter in their tolerance that you can say, I know it's going to be this good. So now we can design how much of X, Y, or Z, in this case, steel, we use. So it's interesting that it isn't just one area being more efficient or more standardized. It opens up the possibility to do things that you otherwise couldn't, whether it's with software or, again, if some of the inputs have less variability than they did, some types of robots might become more viable because there are fewer edge cases, or at least you kind of know where they'll be.
Oh, certainly. I mean, we could draw an analogy to just experience, right? For a human worker, right? Like if you're coming across a detail that you've never dealt with before, you're going to have to reach out to your colleagues. You're going to have to think about it. I mean, it's going to take you time to figure this out. And the most experienced workers are the ones who have come across many edge cases in their careers, and they
Yeah.
just have come up with ways on hand how to handle it. And I think what we're doing, where we are right now with robotics and AI, we're in the very, very early stages of it. It's not like we have an internet scale data repository of like how to interact with the physical world. So with our company, like we have to part and parcel um, come up with the data, collect it, so that we can train on it and alleviate what we think is the biggest problem today, which is a skilled labor gap.
Well, having set all of that context, let's talk about what Hardhat does.
Yeah, absolutely. So we're creating tools for the 21st century. So what does a 21st century tool look like and do? Well, first of all, it should be able to perform the work itself, and it should learn to improve, right? And so that's where the AI part comes into play, right? The robotics mantra is dull, dirty, or dangerous tasks. With Hard Hat, we're really focusing on dangerous tasks, right? It's a good excuse to put a robot between a worker and a work front in a lot of cases on construction sites because we deal with a lot of hazards every single day. Construction is still, a very dangerous and deadly industry. And so it makes sense to actually put robots in harm's way in a lot of cases. So to that end, our entry point, we want to focus on electrical work because anytime you have a voltage potential, anytime you have potential energy, whether it's stored gases or electrical potential energy, gravitational potential energy, like heavy objects, that kind of thing, it's probably better to not have a human nearby. And when we spoke with electricians, the first use case we had talked about was actually energizing large circuits. And I think not a lot of people know about this, but energizing a circuit, you're flipping a switch, but you've got so much potential energy behind that switch. There's two main hazards. You could get electrocuted if it's wired improperly, or there's a ground fault or a short. Um, and so that's one challenge, right? If you get electrocuted when you're touching the switch, you won't be able to let go. Your muscles will contract. The other hazard is what's known as arc flash. And so this is when you have this uncontrolled release of current. And when that happens, you get a lot of heat generated. You get, and so that can cause the copper bus bar to actually turn from a solid into a plasma in the matter of tens of microseconds. And that will create a massive pressure wave, a massive heat, release. So you can get burned, you can get blown back. It's just incredibly hazardous. And if you've ever seen, like, if you Google arc flash and you look at some videos, you'll see it immediately. Like, this is Hollywood explosion type stuff happening in real life. And the way we've solved it, that the standard operating procedure is a two-person team. The first person is suited up in a bomb suit. They're the ones actually activating and closing the circuit. And then they have a second person with a shepherd's hook, an insulated shepherd's hook around their waist to pull them away. But that second person is oftentimes still close enough to be in the arc flash blast zone. So they're also wearing a bomb suit. And it's ridiculous to me that this is the best we can come up with. But that's just the nature of potential energy and the electricity in the buildings we use. So we think it's much better to have a robotic system that can learn to perform this work and do other things but to put humans out of harm's way.
Well, a good indicator that maybe a human might not be there is that a bomb suit is involved. But I think
Yeah,
that's a rule we can all get behind.
I think so. I think so. I think we'll write it down here.
That's right. That's
Yeah,
right. Look for the bomb suits.
look for the
So,
most.
and what is it? So, what is the actual item? What is the product? Actually, can
Yeah,
you share it? I bet you got a
yeah.
picture.
I do. So let me share my screen real quick, and you can get a nice glimpse of what the system looks like. So in good construction fashion, we have a utility cart, which, there's utility carts all over job sites nowadays. They're mobile office stations, work desks, that kind of thing. And we've installed this robotic arm on it. And we've also put some lifters on the cart itself to help stabilize it. And I'll just zoom in here. And we've got what we call the finger. And the finger is exactly that. It's meant to flip these types of switches or these types of disconnects. You can also remove the finger part and use it as sort of like a push button device. And this is our prototype. This is our first invention. Um, and so the way it works is you connect to it with a laptop, and you can remotely control the arm through positioning it and then actuating the finger in and out, just using a PlayStation controller. And you get the view from the robot. So we have a context camera right here, which gives you sort of the wider scene, make sure there's no one else in the area. You're actually at the panel that you want to be at. And then we have sort of a close-up view on the tool itself, which gives you that better angle to look at. And yeah, once you're positioned, you can safely exit the electrical room or be outside the blast radius, and actuate the switch.
And I have to ask, where is this picture taken?
Yeah. Oh, so this was at Hensel Phelps's new Diverge Innovation Center. So we were there a couple weeks ago for the grand opening. We're really excited to partner with Hensel Phelps, and be part of this open innovation lab. So this was set up for their demo day, and we got to meet with the public, but also the executives of Hensel Phelps and some of their project leaders, and some of their customers as well. So it was a really cool opportunity.
Yeah. Shout out to Ty and the team. I heard it was a great event. Awesome. So where do you guys stand I mean, you've got a prototype together, which does what it's supposed to do. What's the status?
Yeah. So we went into operations January of 25. So we are fresh company. The prototype was a little bit messier than it is today. But we successfully been on 3 job sites now, using the robot. And then this week, actually, this Friday, so this is the second week of October, we are training and certifying our first user. And so they'll be able to call for the equipment when they are having an energization event, and we'll drop it off, and they'll be able to drive it, operate it, and we'll pick it up when they're done. So we're beginning operations here in the San Francisco Bay Area, but we're generating as much excitement and needs as we can, for other regions. So we have interest from Phoenix, from Austin, Raleigh, Durham, and Jacksonville, have all, indicated like, hey, we would love to work with you and get people out of harm's way.
I love that. And what I just saw, so that was a prototype, so you put different pieces together. But when you deliver it or ship it, does it have the cart with it, or can someone say, "Hey, we got 100 carts here. Just let me snap it on"?
Let me snap it on. So for this prototype, it really is the cart, and so we drive it around with a trailer and all that fun stuff. But we are working on a new design that will be much easier to ship. And then
Yeah,
yeah, if you have a cart or a scissor lift, we'll just be able to attach this
yeah.
to it.
Which is normal product development, right? You get the thing working, and then you figure out, well, people want it to, have wings on it.
Yeah, exactly.
That's awesome. Well, as we kind of bring it in, where do you see both what you're doing, but also robotics more generally? I mean, there's a lot of talk now. It's almost like there was ChatGPT, 3 years ago, and now robotics is starting to. You're hearing about some humanoid robots. Of course, Elon Musk says we're going to have 1 million robots next year. That's Elon time.
Yeah.
But it seems like a number of technologies have matured, or let me rephrase, have evolved to the point where, just like you mentioned with diffusion policies and was it action chunk transformers? Somebody's going to go do some research today. But my point is, there's new things that have come out, just like LLMs are because of the transformer, and that spawned a whole bunch of things. How do you see things going over the next couple of years?
Yeah. So I think there's going to be an enormous push for data collection, and there are lots of methods to do it. I think the gold standard is this what we call imitation learning, where you have a teleoperating a person teleoperating the robot and performing the task. So you might see schools of robots just performing various things. I think there's a lot of interest right now for household and elderly care. And so you're seeing a lot of demonstrations on folding laundry, cooking, those kinds of tasks that robotics have just never been able to perform before. You're also seeing a interest and a push into industrials. So a lot of humanoid robots today, which this is where all the money is going. So you're seeing a lot of development because we are the most general purpose thing we know. So we're making it in our own image. But the strengths really aren't there for industrial use cases. So it really is limited to more household type items or tasks, I should say. But yeah, expect to see, I think, a lot more automation. I think it's going to be driven. There's a small window of opportunity, I think, for the next 10 years, where we have this gap in skilled labor here, especially in the US. Because of the millennial generation transitioning into and taking over from Generation X. But Gen Z is starting to go more and more into the trades. Now it's a 5 year lag, plus, there's going to be, I think, more attrition in construction. So I'm saying 10 years, basically. I think you're going to see a lot more robotics. I think you're going to see a lot more attempts at data collection. There's going to be people who just say, "Hey, let me just put cameras on your job site or put cameras on your people," and um, it generally doesn't work so well if you're not offering some sort of value um, to contractors. But yeah, I would expect a lot more recording, a lot more attempts. We'll also probably see a lot of hand tools turn into robotic tools, right, with interfaces for the robots themselves.
Yeah, I love it. Yeah, I can sort of see that. I'm in Austin, Texas myself, and once in a while you'll see one of those delivery robots, which I think that's going to be a social thing as much as anything else. Having robots walking around or rolling around on the sidewalk, there's going to be a period where people knock them over and do silly things and then they get used to it. But that's just kind of, it's such a different thing. So, these are still robots when you see Waymos, and seeing two Waymos in a row is a weird experience. One of them and you're like, oh, interesting. But you see two and you're like, we're done.
We're done. Yeah. But here's the thing about this. So I think there is a debate and there's a way to discuss like pure automation versus tools, right?
Yeah.
And we're definitely in the camp of a tool, right? We want humans to intervene. We realize the practical limitations of the technology today, and we're providing a solution. Now we want to ride that wave and capitalize on tech developments and data collection and all that. But in the end, I think ChatGPT and these LLMs have proven that they're a force multiplier for a lot of folks and not necessarily a pure automaton. Um, and so my hope is that we can make people a lot more productive, but still have good paying jobs and, achieving their dreams and goals. And maybe one day, if you have a dream of building a building or an installation or something like that, you can have some robots help you with that. And it wouldn't require moving so many resources or materials to make that happen. And maybe puts more art or creativity into the hands of people who are not builders, right? I think that's a dream I have. And it's also an opportunity for people who are differently abled to get into the industry. You don't have to be this big burly dude who can lift bags of concrete anymore. Maybe the robot can do that for you.
What's interesting also, though, is that as technologies evolve, there's 2 points I'll make. One of them is every time we try to recreate what humans can do, whether it's mental things or physical things, we realize how hard it is. And I don't mean physically hard, but how much our brain is doing. And it's like,
Yeah,
wow, that should have been easy. There's a thing called Moravec's paradox, where it's things that are easy for humans are hard for AI. They're usually talking about, and
sure.
that's because the things that we take for granted are often the hardest things, and the things that we think are hard are actually easy for AI, or in this case, robotics. Um, yeah, super interesting. Awesome. Well, listen, Henning, thank you for the time. I love hearing about what you're doing. So when we publish this, I'll put a link to your website so people can check it out more and ask you
Okay.
what you're up to.
Awesome. Thank you. I really appreciate it. Thanks for the time, Hugh.